name is Nathaniel, and I welcome you to another episode of our mathematics for secondary school 1, for senior secondary school. And then in this episode of this video, we are going to be talking about mensuration. And in mensuration, we're talking about solid shapes. So what are solid shapes? Solid shapes are the shapes that you can feel. Those are not just plain shapes. They are shapes that have length, they have breadth, and they have height. So basically, solid shapes are basically those shapes that exist in the 3 dimensions. So you also call them your 3D shapes. Those shapes that you can see, you can feel that they have depth, they have length, they have breadth. So those are solid shapes. For example, when you see a block now, a block, so and that block can be a concrete block, can be a plastic block, or whatever it is, any block you see, that is also known as a cylinder. Rather, it's known as a cuboid. So blocks are generally known as cuboids. That is an example of solid shape. A cuboid is something like that looks like an elongated cube of sugar, or a book is in the shape of a cuboid. Or maybe we have a charger. The charger of your phone could be in the shape of a cuboid. But at times, most of these products, you have them, the edges are curved. So whenever you make an alteration to a solid shape, it no longer becomes a solid shape. So when I'm talking about cuboids and cubes, those are called prisms. Now that's the first thing we're talking about in this video. Prism. A prism. What's a prism? A prism is a solid which has a uniform cross section. So when I say uniform cross section, when everything is straight. So something like this. Look at this thing I'm drawing now. So for this cuboid, you can see that everything looks straight. So the height is everything goes up and then it joins on a flat surface. The top is flat, the bottom is flat, this side is flat, this other side is flat. But it's not necessary that all the sides must be flat and straight. But it is necessary that they must have a uniform cross section, and that means that they must be uniform. That means the height must be uniform. So we can see that this has a uniform height. It looks just regular. It looks so regular. So a prism is basically a regular shape that is not really regular in the total dimension, but just in the height. The height is regular. It goes up with a regular pattern. So for example, when you have something that has a triangular base like this, and this triangular base, you pattern it up. When you pattern that triangular base up, and then they all join at the top. So when the top is similar to the bottom, it's called the prism. So that's another way you can recognize the prism. For this shape now, you can see that the bottom has a triangular shape and the top also has a triangular shape. For this shape now, you can see that the bottom is in the shape of a square and the top is also the shape of a square. So whenever you have a square-based prism, it's called a cube. This is a cube, and this is a triangular-based prism. When you have a rectangular-based prism, that is when you have the rectangle at the bottom like this. But if I draw something like this, and we have a rectangular bottom like this, if the bottom is rectangle, it's called a cuboid. C-U-B-O-I-D. So there are different types of shapes like this, but let's talk about how to find the area and the volume of these shapes. So for a cube, the area of a cube is 6 if the length of one side is s. So because a cube has all the sides equal, and the reason for that is that a cube is a derivation of a square. It's a 3-dimensional shape of a square. So if you want to further your mathematical knowledge in other areas, you'll be dealing with geometrical shapes like ellipses, parabolas. So those are all geometrical shapes, and they are all formed. For example, your ellipsoid is formed whenever you take the 3-dimensional form of your ellipse and your other conic sections. So I'm digressing, but that's essential so that for those of you who want to further your knowledge. So I will still make videos on that, but let's focus on this. Now the surface area, total surface area of a cube is given by A is equals to 6s squared, and the volume of a cube is given by s cubed. So in our algebra class we talked about the powers. This is called exponential. So this means x raised to power 3, s in 3 places. And this 6s squared, that's 6 times s in 2 places. 6 times s. The volume is s cubed. That's s times s in 3 places. So that is just an explanation. Then for this one, you also have the volume of this one, but for shapes like this that are not cube, that are neither cubes nor cuboids, let's just generally call them prisms. And then the general formula for calculating the volume and area of a prism is, for the surface area, you have to calculate the area of every side. So for this one, you calculate the area of this bottom side, the area of this one plus the area of this one plus the area of the top face. So of the faces, you calculate the area of each of the faces, and then you add them together. So the total area of this shape is the summation of the area of each face. That is how to get the area. Then we have your cuboid. The area of your cuboid, or you can call it surface area. The surface area of your cuboid is length times breadth plus breadth times height plus length times height. So you multiply everything by 2. So that will be 2 length times breadth plus 2 length times height plus 2 breadth times height. Then your volume of a cuboid is length times breadth times height, LBH. So this is just a revision of most things that you would have covered in your junior secondary school. And if you still don't understand all these basic concepts, you can go back to the first episode of this video, which I covered a revision of junior secondary school work in mathematics. So moving on, now this is a prism. These are selected prisms. For example, let's move on to talk about a prism. When a prism has a circular base and the base is the bottom, so when the bottom is circular and then you project that up, so I said in a prism the top and the bottom are identical. So that means if the bottom is circular, the top will also be circular. Yeah. So for this prism, we have a circular top and circular bottom. It's known as a cylinder. So and then you still use the same method to look for the area and volume of a cylinder, because the volume will be area of the base times the height. So any prism you see, any prism that you don't know the area, you can just say what's the area of the base. The area of a circle, of the circular base, is pi r square times the height. That's pi r square h. That's the volume of a cylinder. So the V is equal to pi r square h. Then for the area, you just look for the area of a cylinder will be 2 pi r open bracket r plus h close the bracket. So that is 2 pi r multiplied by the summation between the summation of r and h, where r is the radius of that circular base and h is the height. That's the distance from the top of the cylinder to the bottom. So now you shouldn't get tired of all these dimensions in mensuration, because we deal with them a lot. We deal with dimensions a lot in mensuration. So and that is for prisms. So example of prisms, we have cubes, we have cuboids, we have cylinders, and then we have triangular prisms. So and they are unique. So if you don't know anything about a prism, if you don't know, always remember that the top and bottom are similar. So the top of this one is a square, the bottom is also a square. The top of this is a triangle, the bottom is also a triangle. The top of this is a rectangle, the bottom is also a rectangle. The top of this is a circle, the bottom is also a circle. So the top and bottom of a prism are similar. Now mensuration will mostly deal with prisms, but there are also other things in mensuration. For example, you have cones. So cones, basically, a cone is basically it looks like a pyramid. A cone is a pyramidal structure, but with a circular base. So now you would have heard of cone in your junior school, so I wouldn't want to talk about that here. So let's just move on to how do we derive what's the relationship between a sector of a circle and a cone. For example, if we have a circle and we cut a sector out of the circle, I will use it to form a cone. When we fold this sector, let me highlight it. Now the angle subtended by this sector is theta. Now if we fold this into a cone, you can see that this side will form this side. So this will be, if this is r, big R, then this will also be big R here. Big R. Then what of this one? If we fold it, this becomes what? This becomes the circumference of the base circle. This circle at the bottom of the cone, the circumference will be equal to 2 pi r. So this one is 2 pi. That would be 2 pi r. The formula for finding the area of of this circumference of this bottom will be 2 pi r. Well, that will be small r because this one has its own r. There's a new radius of the base circle of the cone, but that will also be equal to the length of this arc, and that will be theta over 360. Remember, in a previous video we talked about that, times 2 pi big R. So if we divide both sides by 2 pi, we'll get, at the end of the day, we'll get R is equal to big R times theta over 360. So the radius of this new cone is proportional to the radius of the second cone by your angle, the angle of the sector, and 360. So rather, let's just say it's proportional to the angle of the sector. So if the angle of the sector increases, the radius of your cone formed also increases. So this is one of the basic formula you use for calculating the a cone whenever you have whenever it is formed from a sector of a circle. So this is something you will be doing in SS1, and you need to understand it. This is just the formula. The small r is equal to big R times theta over 360. So if you know it, you can also skip that. Let's move on to the cone itself. So what is the formula for calculating the total surface area of the cone? Now, a cone has two distinct surfaces. It has the base, the surface of the base, and then the surface of this curved height. So this curved height that tapers to the top of the cone, each of them has their area. So the total area of a cone will be the addition of this area. So the total area of a cone, A, will be equal to what? Area of the base, that will be pi r square plus the area of this curved side. Now the area of this curved side, the area of this is pi rl. That's the area of this curved side. So the total area of a surface area of a cone will be pi r square plus pi rl. That is the formula for calculating total surface area of a cone. Then lastly, let's talk about the volume of a cone. The volume of a cone is given by the area of this part times the height, then divide by 3. That's 1 over 3 area of base times height. So area of base is pi r square. 1 over 3 times pi r square, small r, times the height. Let the height be h. So the height is the perpendicular distance from this apex, this point, this very, very top of the cone. When you draw a perpendicular to the center of the base circle, you get the height. So that is called h. Let's call it h. That's pi r square times h. That will be 1 over 3 pi r square h. Now, in general, for any shape like this, the formula is usually 1 over 3 pi r square h, and these are generally known as pyramids. So a cone is basically a special type of pyramid that has its base as a circle. But the formula for calculating the volume of a pyramid is 1 over 3 the area of the base times the height. That's 1/3 the base and height. So that is all for that cone. So these concepts we are talking about, we'll be talking about them today, and then we'll also be taking that into another dimension, and we'll be solving questions in another video. So, but let's talk about the composite solids. A composite solid is formed when you add another solid, one on another. So in a composite solid, the total volume of that new solid will be the summation of the volume of the initial solid. For example, when you have something like a hut, a hut is kind of like a traditional building. So this hut is shaped like this. It has this roof part and this wall. Now, if you look at this carefully, this is the combination of a cylinder and a cone on top of a cylinder. So the total volume of this object will be the volume of the cone on top plus the volume of the cylinder below. That is, you add them up. But if you are looking for the surface area, you just add the surfaces. So the surface area will be the area of this curved part of the cylinder plus the area of the base of the cylinder. That's we can't see it. Then plus the area of this curved surface of the cone. So you add each surface to calculate the total surface of this composite figure, but then you just add the volume of each of the composing figures. So that means the volume will be the volume of this cone up plus the volume of the cylinder down. So you might not understand totally, but when we get to the part of question solving in the next video, we'll talk about I'll be doing a demonstration of that. Then apart from composites, you also have frustums, and your frustum is whenever you slice a shape into sections, so you get a frustum. We'll talk about that. And a frustum basically simply need to subtract when you want to get the volume, and then you still add the area of the respective surfaces when you want to look for the area. So let's hold it there for today, and then we'll continue from here in another video. Thank you for watching.